Start.
Yeah. So hi guys. Today we are going to discuss about some CCNA topic and the backend process of ARP and G-Arp. We have here Bharat sir, which our CCNA instructor, and for Networkers Home, we are doing live this YouTube channel for that G-Arp and that concern. This series is going on. Will take and handle by the Bharat sir. Okay, sir. Now you can start your session.
Thank you, Nikun sir, for the introduction. So, good evening, guys. So, today I'll be talking about the router post process. The router post process, the booting procedure, the ARP, and the G-Arp. So, first, let me start the session here. So, first, let me introduce the post here. So, what is post? So, of course, you might have heard of the term post here. The post is power on self test. Of course, I don't have to tell you about the power on self test. You have already seen it. So when you turn on the computer, you might have noticed about it. So you might have noticed that the computer or the screen might have turned on once, it will flash once and go away. Or you might have noticed about the keyboard lights. The keyboard lights also will turn on once and then will go away. So these are the part of the power on self test. So power on self test, say the word itself says this, power on self test. That means when you turn on the power, it is testing itself. It is testing itself for all the processes and where all the hardware things are present and whether all the hardware things are working fine or not. If at all you have noticed it, if at all the RAM is having some issues, you might have heard of 3 beep sounds. Or if at all, say previously even I have seen it, say if at all the keyboard was missing and then it used to show the keyboard missing. So the computer, so they have a process called post, power on self test. The same thing with the router as well. Now that today we'll be discussing about the router. So the router also say does the post. When it is turned on, say you will or that device will do the post here. So that's the post thing. So that's the introduction of the post. Now then it will start booting. Now before going to that topic, so first let me tell you something here, the types of memory in a router. So you got 4 main types of memories in a router, which are the flash memory, the ROM, RAM and NVRAM. I think you might have heard of this flash memory, this ROM and RAM. And the NVRAM, it is called non-volatile RAM. I'll come to that. But first let me tell you this flash memory. So let me just compare that with the computer. So the computer has got an operating system. You might know, yes, of course, you know it, the Windows operating system, the Linux operating system, everything. So now the router also, they have got an operating system iOS, and this iOS is the internal network operating system which will be there in the flash memory. So the flash memory contains this iOS. Then the next one, it's the ROM, read-only memory. So the read-only memory says, or in the read-only memory or the ROM, it's a chip and you will burn in the values into this ROM. Then you have another memory called RAM. Of course you know about it. So if at all you want to play the games and all, then you might have heard of it. Say you need better RAM. If you want to do many things in the computer, of course you need better RAM. So that is random access memory. And the random access memory, let me tell you more about this. Say whatever that you run, whether it's the game, whether it's the program, whether whatever you do or in the computer, so that is run in the RAM, random access memory. Now, so you might have heard of one thing as well. RAM is a volatile. It's a volatile memory. So whatever that you do, if the power is turned off, then the values are gone. Now in the router, you got another type of memory called NVRAM. So of course whatever you do the configurations that be there in the RAM, and you can save it to this NVRAM. So whatever that you run it is called the running configuration, and when the running configuration is saved to the NVRAM, then that is called startup configuration. So these are the basic things I need you to know before we starting the booting procedure of a router. I hope you have understood this. Now moving forward, so the booting procedure of a router. Now, so I hope you can see the screen. say this router, when it is turned on, what happens first is that, say in the ROM we got something called bootstrap program. So this bootstrap program, it performs the post power on self test, and then say they will check for something, so that value is called configuration register value. So there is a value which is called configuration register value, which the router will check for that value, and which says from where you need to load the operating system, or from where you need to load the configurations. So now you have two main values, 0x2102 and 0x2142. So these two are the main two values. Now if at all this configuration register value, it is 0x2102, now then the IOS, the Internet Working Operating System, the operating system in the Cisco routers, so it will be loaded in the flash memory, or it will be loaded from the flash memory. Now it will be loaded to the primary RAM now. Then again what happens is that then they will check for the startup configuration. I told you what is startup configuration just before. So whatever you run is the running configuration, and if it is saved, that is called startup config, and they will check whether the startup config is present or not. If the value is 0x2102. Now if the startup config is present, it is saved in the NVRAM, then that is loaded to the RAM. Then the router goes to the working state. So this is the simple process, router booting process. Now we'll talk about the next configuration register value, which is 0x2142. If this is the configuration register value configured, then the same thing happens. Say the iOS will be loaded from the flash memory, it will be loaded to the RAM, and then the startup configuration, if it is saved also, the startup configuration will not be loaded. That means, say without any configuration, the router will be loading, and the router will be going to the working state. So as you can see in figure, so this startup configuration is skipped. If the startup configuration is skipped, then the router will ask whether to enter into the initial setup or not. So the router wants us to enter into the initial setup, and then the router will ask for some values, some passwords, some things. So these things will be asked, and we can give those passwords, and whatever it's necessary we can give it. If you give no there, if you do not want to enter into the initial setup without any configuration, without any password, without anything, the router will be going to the working state. So this is the booting procedure. I hope you have understood this one. Okay, now that I have attached some screenshots here, so here, so when you turn on the router, here you can see, so here you can see the system bootstrap version. So here you can see the things about the bootstrap. So here the post happens here. Now then the next thing what happens is that, so here then they have found out, say they have located the iOS. They have located the iOS, and it is decompressed, and it is then loaded into the RAM now. So you can see self decompressing the image, and you can see some hash value. So it is getting loaded. Now the next here, so loading the iOS. So now after loading the iOS, then you can see certain things here about the router. So here if you can see clearly, it says about the iOS. It says the version of the iOS, Cisco iOS version. What is the version? So here it is, the version here is 15.13. This is the version of iOS. Now later you can see the device details, you can see. So it is Cisco 2811 series router. So this is Cisco 2811 series router, and the processor board ID you can see, how many interfaces is there you can see, then you got a VPN module, then you got the RAM, then you got the NVRAM details, so these things, and then the flash details. So these details are shown while loading the router. Now afterwards you can see, I told you, if at all you do not have any configurations loaded, or if at all the configuration is skipped, then they will ask us to enter into the initial setup, or they will ask us to go into the setup mode. If you give yes, then I told you they will ask us to enter many things, of which one thing is a password. If you give no, then without any configuration the router will be loaded. So here you can see the router has loaded now. I've given no and the router, without any configuration, the router has loaded. So this is the first part of the video, which says or which talks about the router's booting procedure. Okay. Now we'll slowly go to the second part. So the second part, say, is the ARP. So our topic was G-Arp, but the G-Arp is graded to as ARP. Before explaining the graded to as ARP, I need to explain what is ARP. Then only you will be understanding it. Now, the ARP here is Address Resolution Protocol. So address resolution. So here the word says address resolution. What do you need to resolve here? So here you need to resolve the MAC address of a device. So here it is, or ARP is, it's a layer 2 protocol used to find out the MAC address using the IP address. So now let me just show you a topology here. So this is the topology. Here you can see 4 machines are connected: PC1, PC2, PC3 and PC4, and they are having 10.0.0.1.2, 3 and 4, the respective IP addresses and the respective MAC addresses. Now if at all the computer PC1 wants to communicate to PC4, then going with the OSI model, if at all you have some data, suppose a high message, then this data will be passed through the application layer. Then they will add some application header. Then it will be passed to the presentation layer, where they'll add the presentation header. Then it'll go to the session layer, which will add the session header. Then with the transport layer, which will add the transport header. And finally here the network layer, which are the network header. So this finally is the packet. So now let me tell you about the packet structure here. If at all the machine 1 wants to send something to machine 2, then the packet will be having the source IP, which is the machine 1's IP, which is 10.0.0.1, and the destination is PC4. So the destination IP is 10.0.0.4 here. Now then it is passed to the data link layer, where you need to add the source MAC address and the destination MAC address. Now the source MAC address, it already knows its own IP address, which is the MAC 1, and the destination MAC needs to be found out, and it will be found out by using the protocol ARP here, Address Resolution Protocol. Now what the ARP will do is that, so here you can see the ARP message. It will be generated by this computer. So the ARP message is actually used to find out the MAC address. Okay, the MAC address of this PC4. So I told you that ARP uses, or it is used to find out the MAC address using the IP address. So the ARP message, or the first ARP message sent by this PC1 is the ARP request. So the first message is ARP request. So it will be requesting. So let me tell you. So if this is the request here, then this will be the structure of the ARP message, where they will have the ARP header and the layer 2 header. And the ARP header, they will be having the target IP. So it is targeted, this ARP request is targeted to find out the MAC address of 10.0.0.4 machine. So the field this target IP field will be having the IP 10.0.0.4, and the target MAC is what we need to find out. Now the source IP and the source MAC will be the MAC address and the IP address of the source machine, which is the PC1. So the source IP will be 10.0.0.1, and the destination, the source MAC will be this MAC1. Now coming to the layer 2 header. Coming to the layer 2 header, say, which is the source MAC here? Of course the source MAC is MAC1, because it is sent by MAC1. Now the destination MAC. So let me tell you about the destination MAC now. This computer PC1 is sending the ARP request to find out who is MAC4, or to find out the MAC address of PC4. He really do not know the MAC address. So he'll not set any value here, but instead they will set a value which is ffff.ffff.fff, which is the broadcast MAC address. So actually he needs to find out the MAC address of PC4. For that he will broadcast it to everyone. If he broadcasts it to everyone, it will reach everyone and the respective machine will be able to send it back. So at the layer 2 you have the broadcast address as the destination MAC. Now what happens is that, say, this ARP request will be sent to the switch, and the switch will check the destination MAC, it's a broadcast, and will be flooding it to all the interfaces here. It'll be flooded to all the interface, and what happens is that the PC2, PC3 and PC4, everyone receives it. Everyone receives it and they will check the layer 2 header. And the layer 2 header says it's a broadcast. Everyone will accept it in the in the layer 2. And they will pass it to the LLC sublayer, where the LLC sublayer will check the IP address and the target IP, whether it matches or not. That's what they're gonna check. So the PC3 will check the same, the PC2 will check the same, whether their IP matches with the target IP mentioned in the ARP request. So here it doesn't match, so what happens is that they will discard. Now the PC4 is the correct machine. They will understand, the PC4 will understand the ARP request is sent, the ARP request is sent for him, and he needs to reply back with an ARP reply. And the ARP reply will be having the MAC address of this PC4 along with its IP address. So this is the ARP reply that is sent by the PC4, and it is reached to the PC1. And the PC1 now knows the MAC address of 10.0.0.4, which is MAC4. So finally the PC1 knows the MAC and the IP of PC4 now. Then he can send the data. So this is the process of MAC address discovery. And say the MAC address discovery by means it is done by using the ARP protocol. Now, so
sir, sorry to disturb. Yeah, here I have a question that you are explaining that it is explaining the MAC also discover and also checking the IP also.
Yes.
It is a L2 protocol or L3 protocol? ARP is?
ARP, it's an L2 protocol, because so it is not really sent to L3. This is now, so I told you that, say you got a layer 2 header and you got an ARP header. It is processed, this ARP is really processed in L2 and it is not passed to L3, but it is passed to LLC, which is a portion of the layer 2. Okay, so you can say ARP is a layer 2 process. I hope that's clear.
Yeah, okay, that is clear. So in that we have also other variety also for ARP?
Yes, of course we have. So that's what I'm going to discuss. Say we have many types here. So G-Arp is there. Say G-Arp is our main topic. So I'll be coming to G-Arp. And other than that, we have proxy ARP and we got, say, reverse ARP, inverse ARP, etc. So now coming to G-Arp. So now let me tell you about the G-Arp. So the G-Arp here, the GRET-E2S ARP. The GRET-E2S ARP is an ARP reply which is generated without receiving an ARP request. So let me make it clear for you. So now suppose, going back to this figure, now so here the PC1 has sent an ARP request. The PC1 has sent an ARP request, and as the reply for the ARP request, this ARP reply is generated. Now the GRET-E2S ARP or G-Arp, it's actually an ARP reply. For a machine to generate the GRET-E2S ARP, it does not require an ARP request. Without even getting an ARP request, this GRET-E2S ARP or this ARP reply will be generated by a machine. Now let me tell you the applications here. So here it is generated for various reasons. Let me just tell you an example here. Suppose, so here you can see the same figure, the only thing that I have added a router. Okay, so I have added a machine, or so here I have added a router here. So of course this router, he will send a GRET-E2S ARP, he will send a G-Arp message without even getting the ARP request. So when a router or when a computer is introduced in a network and whenever he is given an IP, this IP to MAC binding should be updated to the other computers. So to update the IP to MAC binding, if you only update the IP to MAC binding, then only the computers can send the data to this one, to the router. So the computer or this router will send the ARP so that all the machines in the network will get to know that a new machine, in this case the router, has come up or the router has been added, and the router is having so and so IP. So here I've given here, suppose the router is given 10.0.0.5 and the router's this fast Ethernet interface is having say MAC 5. Then what happens, let me tell you. So when you add the router here, the router will send a G-Arp message, and the G-Arp message will be having the MAC address as MAC 5 and the IP address as 10.0.0.5. So it will be sent. And now again let me tell you, I told you it's the G-Arp message is an ARP reply. Now it's an ARP reply. So in the ARP header, so the target IP will be 10.0.0.5. He will put the target IP as its own IP. And of course the source IP is also 10.0.0.5 because the source is this router who is having the IP 10.0.0.5 itself. So whenever a machine is introduced to a network with say giving an IP and all, so he will send a G-Arp like this. The target IP and the source the source IP will be the same, and then the target IP will be a broadcast, the target MAC will be a broadcast, and the source MAC will be the MAC address of the respective interface, in this case the MAC address of fastnet 0/0 of the router. And again going to the layer 2, the layer 2, the source MAC will be obviously the MAC address of the router itself, and the destination MAC, it is intended to send to everybody. If it is intended to send to everybody, of course it needs to be sent to everybody, so the switch also need to broadcast it. So that means they will be keeping the broadcast address. So here in the layer 2 header also you have the destination MAC as the source MAC. So it will be sent in this structure and the switch receives it, and when the switch receives it, of course it will be sent to all the machines except the source interface, and all the machines will receive it, and all the machine will come to know that a new machine has been added with the IP 10.0.0.5 and the MAC address, this MAC address, so and so MAC address, MAC 5. So that is the intention of sending a G-Arp message, a GRET-E2S ARP message. Now let me tell you one more example where the GRET-E2S ARP is sent, or let me tell you one more intention. So here they will send it to update the IP to MAC binding, also to find out the IP address duplication. Consider if this machine is having 10.0.0.5, then if this router is sending a GRET-E2S ARP here, and it will reach everyone including this machine, the PC1, and the machine it will get this G-Arp message, and the machine knows, okay, there is address duplication. I am also configured with the IP 10.0.0.5 and the router is also configured with the IP 10.0.0.5. So finding out the IP duplication. So this is the G-Arp or the GRET-E2S ARP and the topology here. Now let me show you. Yes.
Yes, sir. If we find then duplication, okay. So in that, which IP will remain, like newer IP or older IP?
So there, what happens is that, say they will say in case of any address duplication, they will change the IP. They will have, or they will change this IP to an APIPA range of IP. So if at all they find an IP duplication, then they will change the IP to a specific IP range, which is 169.255. Some x.y range, and this IP range, it is called APIPA, automatic private IP address. I hope it's clear.
Yeah, okay.
Okay. Now let me take the topology here. So G-Arp live packet capture. So now I've implemented a topology here, the same topology, and let me have the router. Let me just connect the router here, and we'll capture the packets and we will analyze it. So now that I'm connecting the router to the fast Ethernet 0/0, and then let me capture the packet here. Now let me go to the router, yes, and what I'm going to do is that I'm going to give an IP address to the router 10.0.0.5 to this fast Ethernet 0/0, and we'll capture the G-Arp ARP here. So I told you that when you give the IP address 10.0.0.5, it's going to generate a G-Arp without even receiving an ARP request. So let me show it to you. So here, let me go to the router, and so I'm gonna give the IP address to fast Ethernet 0/0. So the IP address that I'm gonna give is 10.0.0.5/24. So it is 255.255.255.0, and then let me make this interface up. So it has changed to up, and now you can see, yes, this is the G-Arp ARP. So you can see the G-Arp ARP has been generated by the device. So now again, so here it's a broadcast. So let me take it for you. We'll analyze this one. So here you can see this is the ARP header. So I've just shown you that this structure will look like this. It will have an ARP header and it will have a layer 2 header. So this is the ARP header and this is the layer 2 header. Now, so here in the ARP header you can see the OP code. It's the reply. It's the ARP reply now. Now you can see the sender MAC, which is the MAC address of the router, and the sender IP address. I told you the sender IP address will be same as the target IP address. Both are 10.0.0.5 here. Now the target MAC is a broadcast, and now going to the data link layer header or the layer 2 header, you can see the broadcast. So the destination MAC is a broadcast, and the source, it is the MAC address of the router's fast Ethernet 0/0 interface. So this is what the G-Arp ARP is. I hope both the concept of G-Arp ARP and the router's booting procedure, the post, are clear for you. So now, thank you guys. Over to Nikun sir for winding the session.
Yeah, thank you for the session, sir. Okay, this series is going on. This is our first one, part 1. Okay, so wait for the live session next. We'll continue with the new topic.